We'll try to finish chapter 3. So chapter 3 again is on random variable. So we already defined the concept for discrete random variable. So again, the properties for discrete, as you know, all probability, must be greater or equal to 0. So the probability function we call as probability mass function, or we can also call that one just probability distribution or probability function. Okay, and then the total probability must equals to 1. Okay, and then we proceed with the cumulative probability, cumulative distribution function, where we have capital Fx. So capital Fx denoted as probability x less than or equals to x. Okay, and then we find the expected value and also the variance of a discrete random variable. So when we mention about expected value, so it is the same meaning as we call that one is the mean of x. So we denote this one as capital E, E bracket x, which is summation x times the probability. And then we proceed with the concept for variance. So again, variance is your variability, is part of measure of dispersion. So variance in this case, we use the symbol for sigma square, okay, which is summation x minus mu square. So your mu is your mean times your probability. Or we can simplify by writing ex square minus ex and then square. Okay. And then so the next topic should be on continuous random variable. Okay, continuous random variable. So continuous random variable, again, you have your x random variable on a sample space S. Okay. Again, for random variable, we call your probability function as probability density function. Yeah. Again, suppose that we have the set x from A up to B. Okay, you want to find probability x from A up to B. So that's mean we need to integrate. Okay, we need to integrate from A to B fx dx. So in this case, your fx here is called as probability density function. Okay, or we can writing it as PDF. Okay, so PDF is a probability function for continuous, but if we have a discrete random variable, we call that one as PMF, probability mass function. Okay, probability mass function. So this one probability density function, that's mean fungsi ketumpatan kebarangkalian. Okay, in Malay we call this one fungsi ketumpatan kebarangkalian. So your x is a continuous random variable. Okay, there exists a function which is your fx must be greater or equals to 0. Okay, so if you want to find probability x from A up to B, so that's mean you just integrate A up to B fx dx. Okay, so again, so this one is a continuous random variable. Okay, so continuous random variable. So when we deal with a continuous random variable, for example, let's say you have the type of random variable for continuous, you have your weight, okay, for example, height, maybe time. So this one, this variable will involve either decimal places, fraction, or it can be in terms of interval. So this one belong to the term continuous random variable. Okay. So again, for probability mass function for discrete random variable, have the equality sign or don't have equality signs. Okay, that means with equality or without an equality sign. So it is important for discrete random variable. But in case for a continuous random variable, okay, so if you have this one, probability A less than X less than or equals to B. So it's the same thing, probability A less than X less than B plus probability X equals to B. So it is the same thing if you find probability X between A and B. Maksudnya di sini, if you want to find X between A and B, still you need to integrate from A up to B, fx dx. that you already learned in terms of calculus. Okay, calculus you solve for definite integral. Okay, definite integral. Let's say if you want to find probability between A and B, still you integrate A up to B fx dx. So the same thing, if you want to find A less than or equals to x, less than or equals to B, you will integrate A up to B fx dx. Okay, so as you see here, it does not matter whether an endpoint of the interval is included or not. Okay, however, this is not true when x is a discrete random variable. So if we mention about discrete random variable, if you want to find, let's say, probability x less than 3. So that means does not include 3, you just find x less than or equals to 2. But again, if you want to find this one, let's say, this one is a continuous function, probability x less than 3, for example, okay, we still integrate minus infinity, let's say lah, up to 3 x fx dx. So it's the same thing if you want to find probability x less than or equals to 3, where you still integrate from minus infinity up to 3 fx dx. So that is the main difference between discrete and continuous. Okay, discrete, the equality signs it is important, but for continuous, it is the same thing. Okay, so that means you integrate still the same range. Okay, the concept for this one, again, your PDF, again, you need to show that fx must be greater or equals to 0. Okay, if we have a continuous random variable, your fx, your function is greater than or equals to 0. And then if we integrate, okay, let's say your range is, for example, we write minus infinity less than x less than infinity. So from minus infinity up to infinity, fx dx total probability must equals to 1. Okay. So if you want to find x between a and b, so you just integrate a up to b fx dx. So that is the properties for continuous function, because the continuous function cannot take exact value. Okay, that cannot take exact value. Exact value, for example, let's say if you want to find probability x equals to 3. Okay, so normally for continuous, it can be either in interval, in decimal point, or in terms of your fraction, which involve again decimal point. Okay, so probability x equals to 3 is actually 0. Okay, because your continuous random variable cannot take exact value. Okay, tidak boleh mengambil nilai yang tepat, which is the probability that random variable is equals to 0. Maksudnya kat sini kamu boleh katakan probability x, okay, probability x equals to x must, not must lah, okay, is normally for continuous it is 0. Okay, because it must be in terms of interval. Okay, kita tak dapat nak selesaikan probability x equals to x is equal to 0. It must be in terms of your interval. Either less than, greater than, less than or equal, whatever lah. So it cannot take exact value, which is probability x equals to x. For continuous, must equals to 0. Okay, so how you want to identify whether this one is a continuous random variable or not? Okay, let's say if we refer to the first exercise. Okay, again, I already mentioned to you, x is a continuous random variable. For let's say lah, I didn't put continuous here. So let x be a random variable with the following probability density function. Okay, ada word, kita ada term dia PDF again. Okay, the question for continuous random variable, normally the range is in terms of interval. Okay, if you refer back for discrete random variable, discrete, you will have x equals to 1, 2, 3. So that is normally for a discrete random variable. Okay, the whole number bulat. Okay, but for continuous, it must be in terms of range, which is in terms, normally in terms of interval. Okay, let's say you want to find fxc x squared plus 1, 0 up to 1. Okay, you want to find c. So you want to find c, so that's mean you have your fx dx, okay, 0 up to 1. Okay, so 0, 1, you have c x squared plus 1 dx. Okay, you want to find c in this case. So again, we use the concept. total probability is equals to 1. Okay, so that means you will integrate cx squared plus 1 dx in order for you to find what is your value for c. So the same thing, if you write here, okay, so you will have c, so x cubed over 3, okay, plus x, and then you will substitute 0, 1, okay, set can equals to 1, okay. So then you will have c 1 over 3 plus 1, so equals to 1. Okay, so that's mean you will have c. So you have 3, 4 over 3. So c is 3 over 4. Okay. Okay, you want to find c. So again, we use the concept total probability is equals to 1. So that's mean total, your fx dx, your range from 0 up to 1, set equals to 1, and then you solve for value for c. Okay, so that one is for a continuous random variable. Okay. So the same concept for discrete pun sama. Kalau discrete normally we give you in terms of probability function or a function. So it involves summation. So total probability must equal to 1. So this one, your integration. Integration over your range must equals to 1. Okay, let's say if we have this one. Okay, so again, this one you have probability density function of a random variable y. So you have a value 1 over 5 from minus 1 up to 0, 0 up to 1, you have 1 over 5 plus cy. You want to find c. Okay, you want to find c. So it's the same thing. Okay, you do integration. Okay, so that's mean from minus 1 up to 0. Okay, you have 1 over 5 dy plus from 0 up to 1, 1 over 5 plus cy, and then you set equals to 1. Okay, so again, we will have y over 5. Okay, so if you didn't remember integration, so recall back, okay, the calculus for this one. Okay, so again, you will have y over 5 plus cy squared over 2. Okay, 0, 1 equals to 1. Okay, so y over 5 minus 1 up to 0, y over 5 plus cy squared over 2, from 0 up to 1, set equals to 1. Okay, so again, we will have 0 minus minus, so you have 1 over 5 plus, okay, you have 1 over 5 plus c over 2. Okay, so substitute 0, 0 lah, you get, okay. Set can equals to 1. Okay, so you again, you have 2 over 5 plus c over 2 equals to 1. So find c. Okay, what is your c in this case? Okay, can you give me the value for c? Okay, 6 over 5. Okay, so again, this one, kita nak dapatkan nilai c tu actually. Okay, you want to find c. But you have two functions separate by individual range. Okay, so that's mean from minus 1 up to 0, you have the function is 1 over 5. From 0 up to 1, you have 1 over 5 plus cy. Okay, again, we use the concept total fy dy, and not total integration is equals to 1. Okay, so that's mean you substitute, solve your integration, set equals to 1, and then find c. Okay, so now you want to find probability 0 less than equals to y less than or equals to 0.5. Okay, so try to find what is the value. Okay, so 0 up to 0.5. Okay, the first range is from -1 up to 0. Second range is from 0 up to 1. So now you want to find 0 up to 0.5. Either you use the first range or second range. Okay, because the probability given is just from 0 up to 0.05. Okay, so that's mean you will have, you just want the probability is from 0 up to 0.5. So the function is 1 over 5 plus 6 over 5y. Okay, find the value. Okay, because we just integrate 0 up to 0.5. So the first range is from -1 up to 0. So does not include the probability that we want. Okay, we just want to find between 0 and 0.5. So use the second range, but we just integrate from 0 up to 0.5. Okay, what is your answer for this one? Okay, 1 over 4. Okay, so we get 1 over 4 or 0.25. But this one? Okay, so that is the concept for continuous. So you will integrate over the range, but it depends which probability that satisfy the punya range tu. Okay. Okay, we look at task 3.14 in your module, task 3.14. Okay, you do on your own, task 3.13. Okay, we just focus on task 3.14. Okay, so given here is the total number of hours measured in unit of 100 hours. So that the family runs a vacuum cleaner over a period of 1 year is a continuous random variable. So we have this following density function. Okay. 0 up to 1, 1 up to 2. So that's made from 0 up to 100 hours, 1 up to 2 to 100 up to 200 hours. Okay. So you want to find the probability that over a period of 1 year, a family runs their vacuum cleaner less than 120 hours. Okay, so you want to find probability X, okay, less than 120 hours. So how you want to write 120 hours? Is it X less than 120? Or is it X less than 1.2? Okay, 1.2, good. Okay, so that's mean because we give you in terms of 100. So that's 120 divided by 100. So probability X less than 1.2. Okay, so check the range. So you want to find probability X less than 1.2. So that's mean you will have from 0 up to 1, X dx, and then you will have 1 up to 1.2, 2 minus X dx. Okay, dx. Okay, so 0 up to 1, X dx, plus 1 up to 1.2, 2 minus X dx, because we have two range. Okay, you want to find X less than 1.2. Okay, 0 up to 1, 1 up to 1.2. Okay, so jangan pula selesaikan ini, jangan pula buat macam ni. Ni salah. Bukannya X less than or equals to 1.1. You want to find probability X less than 1.2. Since this one is a continuous random variable. So either have equality or without equality is the same thing. You will integrate over the same range. Okay, so 0 up to 1, 1 up to 1.2. So that's mean if we solve this one, so X squared over 2, 0, 1, 2x minus x squared over 2, 1.2. Okay, give me the last answer. Okay, 17 out of 25. Is it the same answer for the rest? Or you also can give in terms of decimal point pun okay juga. Okay, so 17 out of 25. Okay, try the next one. So you want to find between 50 and 100. Between 50 and 100. So again, change 50 divided by 100. So 100 divided by 100 lah. So that's mean, okay, Wilson get 5. So between 5 yang mana ni? Okay, probability between 50, okay, 0.5, okay. 0.5 less than x less than 1. Okay, check the range. Okay, you want to find between x between 0.5 up to 1. So that's mean from 0.5 up to 1. Okay, first range. So you have x dx. So x squared over 2. So you substitute 0.5 up to 1. Okay, so you got 0.375 lah. Yeah. So that's mean we already find this one is a continuous random variable. We give you the value in terms of your range. So again, less than 120. So check the question is in unit of 100 hours. And then we give you your x between 0 and 1. So that means change, okay, 120 divided by 100. So we just solve x less than 1.2. So that's mean the same thing between 50 and 100. So change between 0.5 and 1. And then solve the integration. Yeah, so that is the concept for continuous random variable. Okay. So again, if you want to check or to verify whether this one is your PDF, so again, your fx must be greater or equals to 0, and then your integration over the range must equals to 1. Okay. If you don't have any question, I just proceed with this one lah, yeah.